And let's look at a few more. For this type of problem, we're asked to determine if the angle in the problem is an inscribed angle, and if so, we need to name the angle and the intercepted arc. So for this one, we're looking at angle CAB, and if it is an inscribed angle, the vertex of the angle will be on the circle. So our vertex is A, that is on the circle, so yes indeed, this is an inscribed angle. And now we need to name the angle. Well, the angle will be angle CAB. You could also call it angle BAC or angle A. Either of those would work. And lastly, we're asked to name the intercepted arc. Well, the intercepted arc is the arc between the other 2 points that touch the circle, so that's that arc right there. So that arc would be named arc BC. You can also call it arc CB. Either one would work. So that's just something to set up to make sure that you know what an inscribed angle is and you know what is meant when you are asked for an intercepted arc. Alright, next problem that's up asks us to use what we know about these problems where we have an inscribed angle and how that relates to the measure of the angle and the measure of the arc. Alright, so here we're supposed to find the measure of this arc right there, arc AB, and the problem is that there's a whole bunch of information missing here. So let's just take a look at our diagram and let's see what we can figure out. We know arc AC is 130, and we know that angle A is 83 degrees. But we also know from our studies that if you have an inscribed angle, the measure of the arc intercepted by that angle, so here that would be arc CB, is going to be twice the angle. So if I take 83 and I multiply it by 2, that's 166. So arc CB is 166 degrees. I can figure that out from what I know there. So that still leaves me with the question of what is the measure of arc AB. Now I can add another piece of information I know. All the angle measures in a circle have to add up to 360. So if I take 130 plus 166 plus the measure of arc AB, that has to add up to 360 degrees. So 130 plus 166 would be 296 plus the measure of angle or arc AB is 360, and with a little bit of subtraction I find that the measure of arc AB would be 64 degrees. So notice I'm having to combine a lot of pieces of information. I'm figuring out this arc based off what we know about inscribed angles, and then I'm adding that to the fact that we know there's 360 degrees in this. Alright, problem 6, we'll take a look at this one. Here we have angle XWV, which is an inscribed angle. Its vertex is here. And we know that the measure of that angle is 10x plus 4. And we also know the measure of arc XV, easy for me to trace, huh? Arc XV is 21x plus 5. And as we said before, we know that whatever this angle is, 2 times that angle will give us the measure of the intercepted arc. So what I can say is I can say that 2 times the measure of the angle, so 2 times 10x plus 4, must be equal to the measure of the arc, 21x plus 5. And now it's all just algebra to solve this. I'm going to distribute that 2 throughout the problem. 20x plus 8 equals 21x plus 5. I'm going to move my x's over to this side. So I subtract 20x from both, and I'll find that 8 equals x plus 5. Subtract 5 from both sides, or simply just realize that something plus 5 equals 8, that something must in fact be 3. So now I've found what x is, but note the problem asks for the measure of angle VWX. So I have to go back and find that. So the measure of angle VWX is equal to 10 times x, but now we know what x is, plus 4. So that would be 30 plus 4, so the measure of that angle would be 34 degrees.